All right, I've copied problems 1 and 2 on the board now. These are the last problems on the worksheet dealing with the last couple of concepts where we're increasing, decreasing, constant, and then finding the location of the relative maxes and mins. So let's take a look at this first function. Following it along, it looks like we start out constant, then we decrease, and then we increase. So I can list these in any order I want to. I'm just going to read the whole thing left to right. Looks like we're constant between this point and this point. Now I've labeled, because I drew these freehand on the board here, I've actually labeled the important points where significant changes happen. If you've printed out the worksheet, I didn't label those points, but you should pretty easily be able to see that that's their locations. I drew the graphs on the worksheet with the computer. That's a little more exact than my freehand. So we're constant between -3 and -1. Notice I'm naming the x values there. We always name the intervals on which something is constant or increasing or decreasing by the x values. Take a look at that in just a moment. Okay. Here I want to include both of those endpoints because the definition is comparative. If I compare the y values at any 2 points on this interval, including those endpoints, I get exactly the same y value. Then we said we were decreasing from here to here, so that's going to be from -1 to 1. Now, I'm naming that in terms of the x values. You'll notice the y values here, actually the low value is -1 and the high value is 1, but I don't want to interpret these as the y values because this portion of the graph also has y values between -1 and 1, but this portion of the graph is increasing. So remember, functions, each input, each x, has to have a unique output or a unique y value associated with it. So I can identify where I am on the function by identifying the x values. Identifying the y values doesn't necessarily put me at a unique location. If I say my y value is 1, I could be anywhere along that interval. Okay. All right, and then we said we're increasing. Looks like from this point on, so that would be from an x value of 1 forever off to infinity. Infinity never gets included, but I can include that finite endpoint because if I compare the y value here to any point to its right, even if it's just a little to the right, we are going up, it does get a little bit bigger. Okay, the second part of the question, we were asked to find any relative maxes and mins and give their location and value. So if I take a look, I do have this lovely plateau here. So I'm going to say I've got 1 is equal to a relative max, and that occurs at all x, almost all x in that interval. Okay. I don't get to include the finite endpoint of -3 because in order to count as a relative max or min, the function has to be defined on either side. So I can't include -3, but it looks like I can include -1. If I look a little to the left, I don't see anything higher, and if I look a little to the right, I only see points that are lower. So this would be everything from -3 to -1. Now, because that's a plateau, 1 is also a relative min. And the relative min occurs at all x in the interval from -3 to -1. But this time I'm not including either endpoint. Can't include this endpoint because the function isn't defined to the left. I can't include -1 because if I look a little to the right, I do see things that are lower, so that 1 isn't the lowest value in any interval that goes to the right of -1. But if I'm somewhere in the middle here, and I look a little to the left and a little to the right, I don't see anything higher, so it's a relative max, and I don't see anything lower, so it's a relative min. All right, so plateaus are sort of the tricky points. If I look here, it looks like -1 is a relative min, and it occurs when x equals 1. The function is defined a little to the left and a little to the right, and if I look a little to the left and a little to the right, I never see anything lower. Looks like the graph just continues going up and to the right, so I'm not going to have any more relative maxes or mins there. All right, so that's question 1. Let's do the same thing for question 2. Okay, looks like we go down, up, down, up, down, up. Okay, so this is never constant, but we're increasing and decreasing on various intervals. So decreasing, it looks like from here to here, so that would be negative infinity to negative 2, and I can include that finite endpoint. Okay. Then we're going to be increasing for a bit, but we're decreasing here. So I'm going to write union negative 1 to 0. Now, I can't include 0 here because there isn't a point here. Okay. That was not in the domain of the function, so we are not decreasing on an interval containing 0. Then we increase, then we're going to decrease again, so that would be union from 1 to 2. Notice again, I'm naming my interval by the x values, because if I just said y was between 0 and 1, that could be anywhere along here, or over here. That doesn't identify a unique location. But if I say x is between negative 1 and 0, that's this interval right here. Okay, so then where are we increasing? Well, let's see, it looks like from here to here, so that would go from negative 2 to negative 1, and I can include both endpoints. We're increasing again here, can't include 0 because there's no point there, but I can include 1. And then we're increasing over here, so from 2 to infinity. And the function here is never a constant. Let's look for relative maxes and relative mins. Okay. If I look for relative maxes, it looks like this is a local high point and this is a local high point, and they both have the same y value. So I can say 1 is a relative max, and it occurs at 2 locations, when x equals negative 1 and when x equals 1. Okay, if I look for relative low points, I've got one here. That's not a point, so that can't be a relative min. A hole in the graph means there's nothing there. But that's a relative low point. This one happens to be lower, but that's okay. If I look just a little to the left and a little to the right, I don't see anything lower. I've got to look far away before I see that. So I can say that negative 1 is a relative min, and it occurs when x equals negative 2. And then I can say 0 is also a relative min, and that occurs when x equals 2. Now, that's not the only place when my function is 0. It's 0 here and here as well. But these locations are not locations of a relative min, because here, if I look a little to the left or a little to and a little to the right, I do see points that are lower. So the only time that 0 is a relative min is the time when it occurs here when x is equal to 2. All right, that finishes up section 1.7 for us. So at this point, you should be able to do the homework for 1.7.